Go and share my screen. All right. Okay, so let's get started. Thank you for joining. This is exploratory online seminar number 62. Today, I like to present the survey data analysis part 3. We have done the survey data analysis part 1 and part 2 in the past. So if you haven't, please check out the past recording. You can check, survey data analysis, various data analysis methods there as well. But today, I like to focus on how to prepare the data even before you start the analysis. Sometimes you get the data, but data might not be in the right format for you to visualize or analyze the data. So that's a topic that I like to focus today. But before getting, let me introduce myself. My name is Kan Nishida, CEO and co-founder at Exploratory. Exploratory, we started it in 2016 spring to democratize data science. Since then, we've been building the Exploratory as a software tool to make data analysis and data science easier to do. Also, we provide this type of seminar and training to share our knowledge and skills so that more people can actually use data science by various data science methods to understand their own data. Our vision is everybody can make data-informed decisions. I think that's the world we are envisioning. And to make that happen, we can contribute by democratize data science. And that's our mission, or like a guidance that we, the way we work every day. Okay. And then when we say the data science, mainly like we think it's a data access, data wrangling, visualization, analytics, and then that's part of the communication. These are the 5 components or 5 tasks that are essential to do any data science project. And we build the Exploratory to provide a modern and simple UI to make these 5 things to easier and quicker, and it's more intuitive. Okay, so that's it for the introduction. So let me start again. Exploratory online seminar number 62. Today, I'd like to cover survey data analysis part 3. This topic, particularly in the part 3, I like to focus on how you can prepare the data in the right format so that you can visualize or analyze the data in a more efficient way. And I think this is a topic that's actually very important. Even when let's say you watch the part 1, part 2, I talked about various analytics methods, such as, correlation analysis, so factor analysis, clustering, PCA, text analysis, all that. But if you don't have the survey data in the right format to begin with, then none of that is useful, right? So I think that's the kind of things that people overlook, but I think it's very important. So today, let's focus on that this particular topic. And on top of that, I'm gonna just touch a little bit of correlation analysis once you transform the data, and then these are the things you can do, right? So that's something that I'm gonna talk about that as well. Okay, so here is the agenda, and let's start with wide and long data. I think these 2 concepts, or this concept is very important. So the same data can be stored in various ways, and this is why this, you have to think about this, how to transform the data in the right format. So for example, this data, we have 3 respondents, right? So Nancy, Tom, Maria, and we have 2 questions. And then each row represents each user or customer, how they answer those questions. Okay, and this type of the data, we call it wide data, because the data table, this table format, right, data, tend to become wider when you have more questions or you have more data coming in. Okay, so now we have Q1, Q2, Q3, and then the 4th question comes in or the answer comes in, that will become another column. So it tends to go wider. Okay. Although you can argue, hey, what if like we have more customers or users, then doesn't that go down? Like that means like kind of vertical? Yes, that's true. But this is sort of like a kind of comparison to the other data format, which is the long format. Okay, long format is that in this case, the more questions you come in, and then the data tend to go down, right? So in this case, we have question column and answer column. Question column contains Q1, Q2, and it could be Q3. And then corresponding answer will be presented in a different column. And then how many questions you have, you're going to have always two columns of question and answer. So this type of data, we call it long data. Again, the more data come in, and the data table format of this data tend to go longer meaning vertically longer. And if you're coming from the database background, that all the table, most of the tables in the databases tend to typically have this format of like long data. And in that way, you don't have to define new columns every time somebody add the new questions, right? So in the database world, it's not that simple to add new columns by defining such things. So that might be part of the reason, but tend to have like this kind of format. It's called long data. Okay, so the same data, exact same data, you do the survey, and it depends, what service you use, where the data is eventually stored, maybe the database or maybe the Excel, whatever that could be, but then can be presented in different ways, or this wide way or long way. And it's out of, it's up to the luck. When you receive the survey data, you might end up having the wide format or long format. So now, which one is better? That's the kind of things that we, think about. So before going there, and let's understand something called tidy data. So tidy data, this concept is pretty helpful. So tidy data rules, there's 3 rules. First, each variable must have its own column, and each observation must have its own row. Each value must have its own cell. And these 3 rules are interrelated. And then if you satisfy this, then that data you can call it a tidy data. Okay, so let's find out like what that really means. So each column is variable, meaning, for example, in this case, country, month, sales. These are sales data, and these are called variable. Variable means like one column that value can change, right? Like how it changes. So that's a variable. And then now each row is observation. That means this particular row is the observation of how the certain product was sold in particular months in a particular country. So this is called observation. And then like you have more rows that you observe more data, more customers or more transactions or more orders coming in. And then each cell is a value. This is kind of like, common sense in a way, but that doesn't only not just 2000. It can be January, it can be US, anything. Any cell is basically the value, right? And then observation, you remember like each row is observation, but a set of the observations is a table, or in this case, in an exploratory world or R world is called data frame. Okay. So then is my data tidy? Like, what is this whole tidy data thing, right? So let's look at the long data again. So here we have question column and the answer column, and then the more questions coming in, and then we're going to have more rows, right? So is this data tidy? So each row is an observation, right? So this, to be honest, even to me, sometimes I get confused, this whole concept of the observation. But anyway, so Nancy answered 5 for the question 1. So it looks like this is observation. But then when you see like the question column and answer question column, looks like there are Q1, Q2, Q3, the question 1, 2, 3. Isn't the question 1 be a variable? Isn't Q2 is a variable? If that's the case, shouldn't variable have own column? And that's the kind of questions. But then in this case, well, you can argue that, but also, well, the Q1 can be the value. But the way you should think about is when you look at the answer, in this case, the similar kind of scale, right? So question 1, question 2, question 3, I don't know what are those questions, but seems like the typical survey question, survey answer, which is ranging from 1 to 5. 5 is the best and 1 is the lowest or something like that. So it's always 1 to 5. So when you look at the answer, it looks like the same scale, but what if Q2 is something about the salary? Q3 is something about the age. Then all of a sudden, when you look at the answer, the numbers are completely like not consistent. I mean, like not in the same scale. So there's no point of like analyzing the answer column unless you look at the question and then you separate those. And that's the problem. Like if you have a variable, the variable should have the same scale. And it should mean the same kind of thing, right? In the same context. So that this case, the wide data is more appropriate in terms of like more tidy data. Okay, so look at the wide data in this case, and each row is an observation. That makes sense. So like this one person, this is in this case, sometimes we call it subject. In this case, a user or customer or something like that. And then Nancy answered the 552 for those questions, Q1, Q2, Q3. So each column is a variable, each row is observation, and it's satisfying those like a tidy rule. And in analytics, of course in exploratory, but even without exploratory, it typically, the analytics algorithms, like, let's say a clustering or something, many of the algorithms expect that each row is an observation for each subject. What that mean? What's the subject? Subject is like can be customer, employee, product, country, whatever the like what you interest of yours, right? So in this case, this Nancy, Tom, Maria, let's say these are customers, and that's my subject. Okay, and then so each row is like observation, but also representing something about each subject, and it's unique. We are not gonna see, you're not gonna see like another row of Nancy in this case. So in general, this type of the wide data format is a better fit for analytics because each row is each subject. And what type of the analytics we're talking about? Well, correlation and clustering, PCA, factor analysis. These are the kind of analytics methods that you can use for survey data analysis, and also prediction model. Let's say you want to predict the model for like, predicting, what the salary would be, what the sales would be, or even what the answer would be, and then you might want to build a regression model or a random forest model, machine learning model, and so on. So those are as well. So these analytics algorithms expect the subject to be presented in each row and in a unique way. And then in the exploratory, like you basically select those variables, which variables you want to use to do clustering, for example, or to do correlation analysis. Not just analytics, but also in exploratory, when you go to the summary view, when you have your data is wide format, then that means each variable will have its own column. And then in the summary view, we present in the kind of visualize the distribution or variation of each answer, and also along with the summary information. And not only the summary view, when you click on the correlation button, you get in the correlation mode. This is 2, basically this is doing a correlation analysis, but you can find what are how the relationship with other variables or other columns with the column of your interest. So this still like you want to have the data in a wide format. When do you need a long format then? Well, when you want to visualize the data under the chart view, you want to have the long format. This is also has some exception, but in general, the long data format is better fit for charts. Because the chart, the control of the chart, it's all about x-axis and y-axis. That's the basic thing for creating the bar chart, line chart, other chart types as well. And then also the pivot table, or as well, pivot table and summarize table. Like it's always like this, like a row and a value, sometimes column. And so you're now going to have, assign like each variable to each some kind of control. Typically, like you want to have the question that have all the question types and answer. It doesn't matter because each question will be separated in a different row and different bar. I'm going to cover this topic more detail at the later sections. Okay, so now we know we have 2 types of data, wide and long. This is like 2 big type of the data you see often. Then how you decide like, which data format is right? Well, there's no clear answer. So you should be able to transform between wide and long. And that's the topic I want to talk about. So let's take a look at this one, employee satisfaction survey data. Each row is not each employee because now this data is actually long data. There's a question column and answer column. Okay, so that means each person or each employee might have multiple rows for each as many questions as we have. So then we want to, so let's say like if we want to do some kind of correlation analysis or something like that, we want to transform this long data to wide data. Okay, so that's something that you can quickly do with exploratory. You can select these 2 columns and select spread from the column header menu. And then once you do it, then all those values will, let's say the name of the question will be the name of the columns. Okay, so let's quickly do this. How see like how we can go about this. Okay, so I have this youth survey data. This is like young people. I just download this sample data, but they survey what type of things they are interested in. Okay, but unfortunately or fortunately, the data comes in a long format. And looks like here, key and value. And probably key is a question, the value is the answer. When I look at the summary view, the value is like the minimum, lowest is 1, highest is 5. So it looks like all the questions were in, the name of the questions are in a key column. Answers are in this value column. But the answers ranging only from 1 to 5. There's no like 10 or 100 or 5,000 or anything like that. So looks like this unit is the same, and scale is in a way the same, but it's different kind of means different things, right? For each question, depends on what the question is. So now at this point, what I like to do is I want this, when I go to summary view key, there is a 67 means probably, like this seems like there are 67 questions. Okay, so I want to have each question to be presented in each column so that I can actually do a correlation analysis, meaning what are the questions that are correlated in a positive way or negative way. For example, some people score high on the spending on gadget, my answer high on the politics, which I highly doubt, but who knows, right? So that's the kind of things that I want to do. So how to go about it? So that's pretty simple. So I'm going to set a key and value, these 2 columns. Okay. And then And then like I'm gonna do the select from either way, which column, any of the columns is fine. And then I'm gonna find the spread long to wide. So this is why it's important. Is this data is long or this data is wide? Now that we know this type of data is called long, so long to wide. Okay, so we're gonna spread this. And if I select it and then click on round bottom, and then now all the values of the key column, now you can find those in the column names. And then all those values in the answer are presented as a cells in the intersection of the customer ID or like young people ID and those questions. Okay, so now we have the wide data, which we have like 68 columns. The -1, which is like there's a ID columns. So this is not the question, but starting from action to all the way to the writing column. So we have 67 questions. And then it looks like there's a 1,010 rows. That means we have 1,010 people's answers. Okay. So now at this point, what I like to do is I want to find a correlation. So just to make sure what the correlation means and what the is really all about, I want to just kind of quick summary on the correlation analysis first, and then I'm going to perform, how you can go about it. So when you ask these type of questions, right? Then you present in a wide format now. And then when you look at the data, seems like some of the questions seems to be kind of have the same pattern. Meaning, if you score high on the one question, then you tend to score high on another question. So these two questions seems to be correlated or very related or something. And the correlation is basically like it's easy to understand when you visualize it. One question on the x-axis, another question on the y-axis. And each dot represents each person or respondent. And then when you look at visualize something like this, you can clearly see the people who scored 5 on a passionate about work also score 5 or close to 5 on the my work is important. And then vice versa, like people who score low, then the other question, people score low as well. So it seems like a correlated. And the correlation is about these two relationship between those two variables. Is there any similar pattern? Or more precisely, the increase in one variable can expect increase or decrease in another variable. And there is some kind of like a rule that dictate those relationships. And there's two types. One is the most right-hand side, the strong positive correlation. And then we have the correlation efficient or like a metric. And then we can express it from -1 to 1 range. So 1 is the most strongest positive correlation. It's almost like once you know the answer on the one variable, you know the answer on the other variable. And it's a kind of positive way, one increase and the other going to increase as well. And on the other hand, the most left-hand side, the strongest negative correlation, which means one variable increase in one variable can expect decrease in another variable. Okay, and then the middle is 0. So that means no correlation. That means one increase in one variable doesn't mean you can guess on increase or even decrease in another variable. And typically between 0 to 1 or 0 to -1, somewhere like 0.5, 0.6, or -0.7, or something like that. But by using this value, we can sort of like evaluate the strengths of the correlation. Okay, and then when you go to this is a scatter chart, and then have two variables on the x and the y axis, then you can see that sort of like a relationship. You can visualize that relationship. And also there's a correlation value being calculated by using correlation algorithm. But this, you might be thinking, hey, didn't you just say the visualization is, I mean, the data should be long format for visualization? Yes, this is one exception that actually the data it would be better in a wide format if you want to visualize the relationship between the two questions or two variables by using a scatter chart. So this is one exception. Okay. So now, like we are looking at basically kind of like a positive correlation. Increasing one variable can expect increase in another variable. Same thing, the decrease in one variable can expect decrease in another variable. But it can be opposite way. So increase in one variable can expect decrease in another variable, right? So those are negative correlation. Sorry, I think this is, so that's the negative correlation. But also this slide was meant to be explaining no relationship. So like when you see like, some numbers in one variable, when you look at the other variable, there's no relation or something like that. So in that case, when you visualize it and then you see sort of, I mean, you can't even like imagine like which way the data is moving to, right? So that's that almost like a no correlation kind of relationship. Okay, so having said that, let's look at the more correlation thing here. So first, what I want to do is like go to the summary view, and I'm going to just hide the left-hand side data frame list. Okay, so I can see like sort of like a data variation or distribution for each question. Like this is like an action, and I think this is like a movie, and then this is kind of like a music, and then like a movie or kind of getting all together. So it's kind of hard to see a little bit, but until you get used to it. But when you look at something like this, hip hop, rap, this is like a music, and geography is just interest or something like that. But you can see like sort of like how the each answer or the answers for each questions are valid. But what I want to do is when you go somewhere, here it goes. There's a spending columns. Okay, so what I want to know is, let's say the spending on gadgets, right? So like I'm interested in what other variables are correlated to this spending on gadgets variable or column, so that I can know like people who spend more money on the gadgets and what type of things those people are interested in. And that's something that I like to find out. So what I can do is I can go to the correlation mode, and I'm going to select the spending. So for example, here, spending on gadgets. And then this will calculate the correlation for against all the other variables. And then like this is what I get. So for example, when I see like an action column, then correlation between spending on gadget and action looks like it's positive, because the higher the score on the action is, then the higher on the spending on the gadget. So it's kind of like makes sense, because like maybe like this like action movie, and then you like action movie, and then you might get some gadgets. I don't know what type of gadgets, but that kind of makes sense. And then here, the correlation Pearson 0.23. So it's not super high, but there, there's some kind of correlation there. If it's super high, then it's closer to 1. It's not like that, but it seems like there's some positive correlated relationship between these two. And I want to find out like, what are the other interests or the questions that are highest or most correlated to spending on gadget. So I can sort it like from here. I'm going to use it correlation or R-square. You can use correlation, but the problem with the correlation is correlation value is from -1 to 1. So if you use correlation to sort all the variables, what happens is starting from the correlation value closer to 1 and all the way to 0, and then eventually going down to closer to -1. Here, I want to find out, I don't care if it's positive or negative, but I just want to find out the strongest correlated relationship right? So that then maybe even negative or positive, I don't care, but I just want to know what are the things that like I can sort of like use to guess or estimate what would be the spending on this particular person. Okay, so in that case, I can use R square, which is simply you just square the correlation value. Okay, so I'm going to select the R square. And then now, like basically sorting from the highest R square. Here it is. So like the highest one is 0.11 and highest correlation is 0.33. Again, it's not like a perfect correlation. I mean, like strong correlation, but there's some correlated relationship here. So that means entertainment spending on looks. So I mean, people who like spending on maybe they like spending on any type of things, right? So, but the important thing from here, the PC, cards, science, technology, internet, action movie. So these are the types of things that people who score high on these questions tend to spend high on the gadget. Okay, so that's something that, so if you have something to know, particular variable, then this correlation mode will help you to find what are the variables that are correlated to variable of your interest. So next thing here is now, what if it's not like I have a particular variable, a particular thing I want to know. I just want to find out what are the variables that are correlated to one another and which combinations are highly correlated compared to other combinations of the variables. Okay, so in that case, we can go to the analytics view and then select this correlation. And then under the variables, I can select all the variables of I'm interested in. So I selected 67, all the variables, and I click OK, and just run it. And what this is going to do is check every single combination of all these variables and find which variable, and then visualize the correlation efficient values or the metric. Okay, and when I see here, the higher the correlation, the positive correlation is red, and then higher higher or lower, but with a stronger, the negative correlation is closer to -1, is presented in blue color. Okay, so when I see here, looks like, for example, here, like medicine and biology, these are the interests that people have. And so if you are interested in medicine and tend to be interested in biology as well, and vice versa. And other things, for example, here, like I can see fantasy, fairy tales, these are the movie. And then if you're interested in these things and, not this one here, then you're interested in animated, this is also movie. So it kind of makes sense. But this way, like you can find, the correlated relationship among, between any given variables in a very quick way. So this is what I mean. If you have the data in this wide format, then you can use a summary view or some of the methods under the analytics to do such analysis. Okay, so that's a correlation. The next correlation analysis. Next topic is transforming the wide data to long data. This is kind of weird because we just transform long data to wide format. Now you're telling me transforming the wide data back to long data. So this is, sometimes this happens. You want to transform between long and wide, back and forth. So it's better to be able to do such when it's needed, right? So now right-hand side, that's a long data, and somehow you want to transform wide data to long format. Why? Because in general, like you want to have the data in long format so that you can visualize the data more efficient way. So because in chart, it's all about x-axis and y-axis. You assign one column to each, then you should be able to get that chart. But if the questions are like valid on the 67 columns, you can't. There are a way to do it, but it's almost like not possible to get that simple chart. And the same thing for when you're creating a pivot table or summarize table, it's all about row and value or row, column, and value. Okay, so let's do the transformation from wide data to long data. So when you do it, basically you want to select all the variables or columns. Then from the column header menu, you select gather wide to long. Okay, so this one too, let's see quickly the demo. So what I want to do is we just spread the data, and I want to just bring this data back, right? So this is some kind of ridiculous thing to do, because sometimes what happens is like you get the data in a long, wide format. Then somehow like you need to visualize in a certain way, then you do wide to long. But in this case, I started with long and transformed to wide, but I'm gonna bring it back. So please don't tell me, well, instead of doing that, like, why don't you just go back to the previous step? Yes, but for this demo, I'm gonna just transform this wide data to long data. Okay, so I'm gonna select the beginning column and all the way to the end. And sometimes this is like only 67 columns I had to select, but sometimes what happens is you might have 300, 500 columns and you can't really select those, or it's kind of cumbersome to select those. Sometimes you have the different columns that like you don't want to select in the between. In that case, you can use instead of shift key, you can select command key to select certain columns. And also you don't have to select all of them, because from the column header menu, you select gather wide to long. In this case, I'm going to use a select range because I know the beginning column, the end column, all the columns between. So I'm going to select the select range column. But here you can adjust it. So if, for example, like you have the starting column and the ending column is still in the kind of middle, you can come here and then find the very end and then select the ending column as well. Anyway, so I'm going to just give the name to the key value column. These are the two columns you're going to end up having. So the first one, this should be question. This column will have all the values from those column names. Column names are the value. And then the value column, that's the answer. So I'm going to just put answer. And then click on run button. And then this gather all those columns into question and answer, or key and value two columns. Once you get into this mode, the cool thing is you go to the chart, and then like I'm going to just, let's say, like select the bar, and then select the question for the x-axis, answer to the y-axis. This default is sum, doesn't make sense. I want to see the average score for each question among all these like 1,000 people. And then I'm going to sort it. And what I can see quickly here is, okay, so people are very interested in music, movie, and fun with friends. These are the things that people tend to score high. And on the other hand, these are the things, writing, gardening, and physics, and those are the things that people are not that interested in. Not that like nobody is interested. There are people interested in, but there are more people not interested in these topics. Okay, so this is kind of a long data that you can quickly visualize this way. And I want to move to the next topic. Okay, so this is the last topic. So we were talking about this wide data and the long data, right? So these are kind of between, going back and forth and stuff. But sometimes there are another type of the data that you want to transform or clean up before you visualize, analyze. So that's this multiple answer questions. Okay, so sometimes like you can check multiple things, right? Or you can free text, you can just type like a comma separated entries. And then like when you get the data, what happens is that one column contains multiple answers or multiple values, typically separated by comma, sometimes colon, sometimes other characters. And then the question here is, well, in this particular data we are looking at, this is like a Kaggle. Kaggle is sort of a community for the data scientists. And then they did a survey with these data scientists, and then they ask them, hey, what are the data science or the machine learning algorithms do you use often at your work? Okay, and then of course, like people said, okay, I use linear regression and then random forest and then decision tree, and people tend to use multiple things, not just one. So this is the data of the answers. But I like to know what are the algorithms that are most popular. At this point, I can't answer that question because each row, each cell can have like multiple things. I can't even count how many linear or logistic regressions among all these people. So what I like to do is separate each answer into each row. Then I can do like a counting of like how, based on like a number of the rows. So for example, in this case, Nancy answer A and E, and I want to transform this data into Nancy answer A, Nancy answer E. That in this case, Nancy is repeated as many answers as she has. But however, if I'm just focusing on the answer column, then I can answer the question of like, oh, how many A, how many B, how many E kind of things. Okay, so to do that from the column header menu, you select separate. And there are two types of separate, and one is separate to columns, another is separate to rows. In this case, I want to do the separate to rows because I don't even know like how many algorithms are in this data. So it's better to into rows. Rows is more flexible, and then like I can do the counting on that particular column. Okay, so let's do this. Again, for this, I'm gonna use Kaggle survey data. Okay. So each row is each respondent or each data scientist, and then here are the answers here. And then like I like to transform this data into multiple rows for each person so that like each row will have one algorithm. Okay, so select the separate and then separate the rows. And how those values being separated here, in this case, a column. So I'm going to select the, not a column, comma. So I'm going to select the comma here. And then I can just run it. And then now like all of a sudden 28,000 rows, originally I had 9,267 rows, meaning 9,267 data scientists. Now those are presented in multiple rows. That's why we have more rows. But each row should have only one algorithm name. Okay. And then when I go to the summary view, now I know how many algorithms in this data. Looks like there are 15 algorithms. And from here, I can click on this chart icon and I can see that sort of like how many people said, they use particular algorithm more often than the others. Okay. And here though, one thing you need to be careful. Here the gradient boosting machines, and I'm seeing gradient boosting machines here as well. There are maybe other stuff too, like this is a dense neural network. I see dense neural networks here as well. And this is what often happens is that sometimes when you separate by comma, there's an extra space if the extra space is in the data, and then even though it looks same, but consider as a different, especially when you present in the bar chart or pivot table. So what that means? So for example, sometimes it's hard to see it, but I'm gonna go with here from algorithm column header menu, work with text data, and under this work with text data, there is remove, and then what happens is like there's something to do with the space. So I'm going to select this remove space. The couple options you can change that later, but let's say like extra space or leading or trading spaces, and that you would use often. So if I'm select this, and then in this dialog, this is why like I wanted to use this dialog to show you, because it shows a space, right, as an icon or like a particular letter. So you can see like exactly where the space is, as long as this option is checked. And when I look at here, the transformer networks, and at the end, there is a space here. Same thing, gradient boosting machine, there's a space at the end. Okay. So I want to get rid of this so that, to do, you can select this leading and trading spaces. That is the beginning at the end. Okay. And if I click on preview button, and then, for example, that gradient boosting machine, there's no space at the end anymore. So that means this gradient boosting machine right here, and this gradient boosting machine used to be treated as a separate values, but now it's going to be treated as the same value. Okay, so if I click on run button and then go back to the chart, and then right now, still the gradient boosting machine are treated separate because this chart pin button is still pointing to before trimming those spaces. So I want to point to the data that is after we trim those leading and trading spaces. And then now, like when I look at it here, the gradient boosting machine, there's only one gradient boosting machine, and then I can see this is 3,617 is really the number of the people who said they use gradient boosting machine or XGBoost type of algorithms. Okay, and then I said like why this kind of thing happens. So before this is a step we separated. And even before separate, this data, sometimes what happens is, see this here, somehow there's a space right before the comma. I don't know why, but this type of data, somehow you can't control it. The data you have, sometimes the space in the unexpected places. So it's always good to visualize like bar chart. It's very simple and make sure, same value, looks like same value, but somehow presenting different bars. That's where like you want to do this type of operation. Okay. So that's it for today. So basically what I cover how you can transform the data before you go to analytics or visualization. But also it's not like, you have to get the perfect data or anything like that. Typically what I do is I go to visualization or analytics first, or like a summary view and a correlation mode first. Then I realize, hey, I can't work with this. I cannot work with this data. Then what should I do about it, right? So like that's how I approach. So if you can work with the data, like let's say like you had the survey data, you go to visualization, you can visualize, that's fine, right? So like it's not like there's a rule, but if you think it's like somehow like you want to do a particular thing, but you can't do because of the way data was presented, and that's where like you want to consider, hey, if this data is longer than Y, maybe like I should switch between those. Or maybe like multiple answer case, you want to actually separate into the rows. And those are the things you want to consider. And then once that's done, then you go to the visualization or chart or analytics view to continue on your data analysis or survey data analysis. Okay, so our online seminar, you can find the schedule and then the past recording. You can find from our website. I'm gonna show you quickly. Here's our website. And then when you go to here's a LAM menu. Under that, and there's an online seminar. If we select it, then you can see any future seminar schedule. So I'm planning to do like survey data analysis part 4 next week. And I like to cover like factor analysis, text analysis, because we enhanced this area in the past few releases. So I have done this in the past, but I want to do more like kind of updated version of those. Okay, and if you're interested in the past seminar recording, you can click on this one, this link at the bottom of the page, and then you can see like all the past seminars here as well. Okay, and then another thing I like to also talk about is under the LAM menu, there's this like a how-to tutorials on the video. Especially when you go to how-to tutorials, then you can find tons of notes, how-to information you can find. So if you're using Exploratory and you're not sure like what to do in the particular things, and you might want to take a look at it here. And even then, like you can't find it, or you don't even have to do this. Just answer the question by clicking on this chat icon at the right-hand side bottom. or using the exploratory, there is here open chat button, left-hand side bottom. Then ask the question. Then some of us give you the pointers if we already have the information. Otherwise, we're gonna answer the try answer the questions, and then might create a new note. Okay. So with that, if you have any question, please feel free to reach out to me. My email address is kan@exploratory.io. We also have the Twitter account, Exploratory Data. We make announcements like seminars, upcoming training, or releases, new releases, and so on. With that, I'd like to open up for Q&A. If you have any questions, please ask. Otherwise, I'm going to check the chat window first. Okay, there you go. Okay, so one question from Gustavo. If one gets survey data in a long form, is it also better to do all of the data wrangling, cleaning while in the long form before converting to the wide form? Yes, that's a good question. If you want to clean up your, for example, like text values in a answer column, and then yes, it's better to do that type of transformation or the cleaning up thing in the long format, because the number of the columns you are dealing with is only 2 columns, right? So that's actually a good strategy to go. You can always transform it back. And the Kamau answer that it doesn't matter. Yes, that's true too, because you can always go back and forth. And then another question looking for, okay. And then Gustavo is looking forward to the regular expression seminar in the future. Yes, I'm planning for that, so please. And if you have, Kamal, do you have questions?
Yeah.
Yes.
So I really appreciate that kind of separate into rows kind of feature where you can take the multiple choice responses and clean them up.
Right.
So this is a little bit of a question, so maybe some advice. I'm looking for some guidance here. If you have a survey that has multiple of those questions, do you separate the data set into different data frames so that each one ends with one of those questions? Or is there a way of dealing with multiple columns that have multiple choice responses without creating more rows than you need?
Right. So let me sum up that question. So when you have like those multiple multiple columns of multiple questions, is that what you're asking?
Yeah.
Okay. And in that case, should we separate into a different data frame, or should we just somehow keep one data frame and then different columns? Yes, I think that's a good question. Sometimes what I do, like easy, simple way, because I don't like to be confused. So then I use the branch. I create a branch of the data frame and exploratory. And then, hey, this is for the algorithm in this case. And sometimes maybe like the next question is a visualization or chart types, which chart you use often. And then that's also multiple questions. In that case, I'm going to create another branch. And then like I separate into the rows and then visualize if that's the final things. And then like I'm going to use a dashboard or something like that and bring all the charts back. Or sometimes then I can actually merge all the data back together. So I can create 3 branches of the data frames, and I can merge those back as a one single data frame as well. So that's the very simple way to do it. And of course, you can actually combine those multiple answer columns. So like selecting multiple columns and unite those columns. Okay, and then now like you have like already, let's say like a 10 column separated values, one column, another column also multiple comma separated, get together, all comma separated. But sometimes maybe some of the answers are like machine learning algorithm, some of the answers are statistical algorithm or something like that. But similar things. So like I like to have like one single column, and then once you unite first, and then you separate into multiple rows or different rows, and you can do that as well. But once you start doing that, it's a little bit complicated. So you tend to have like some kind of weird mistakes and stuff. And then because you kind of lose the context of like, hey, these are multiple values, but what the answers for, right? So that's why like I like to kind of separate into multiple different data frames first, and then if it's necessary, merge together, because sometimes you want to bring those things in a one single chart. But if those can be separated in a different charts, but in the same report, then keep that as different data frames, create different charts, and then use dashboard or node to bring them all together.
Thank you. And it sounds like the only thing that would be limiting you at that point would be how much memory you have on your computer to process.
Yes, that's right. Yeah, that's right.
Right.
Yes. But it tend to be, if it's kind of like a similar thing, it's we use R, backend, but it does pretty smart things or like efficient things, so that it doesn't copy the exact same thing. So only the difference, you create a branch data frame, it create only some kind of different part of the data. So it doesn't copy every single thing. So you don't want to worry too much about the memory consumption, but yes, there is a memory increase as well. Okay, thank you, Kamal. All right, Gustavo, go ahead.
Thank you, Ken. Can you hear me?
Yes, I can hear you.
Yeah, I think going off of what Kamal was asking, and it kind of takes a while to kind of get a handle of branches and how do you best utilize it. I mean, one of the beauties of exploratory is that you can do, it's very flexible, but also you can get, very complicated in how you split your project. So I wonder, if it's also, part of, when you're doing your data prep, you should be doing all of that up front, and then create multiple data sets for analysis. And then, when you think about it as creating multiple data sets for different analysis, that's when I started kind of doing the branching. I'm kind of prepping the data, and then I think about, well, I'm going to ask, I'm going to try to answer a series of questions, and I'm going to use this data set for that. Then I kind of create a branch for that. Mm-hmm. Then I might go back and have a whole different set of data that will require different kind of wrangling and cleaning, and then I'll create a different branch for that. So when I do that, sometimes I get confused whether, is there any limitations when you create branches that you can't really insert any steps before that, or even after you create branches, you can kind of move any steps either before or through, or to duplicate them in multiple branches? I mean, you still have that flexibility, right? Or is there any limitations that we need to think about before we do that?
Oh, okay. Yeah, so the only limitation you have with branch, which we want to address in future releases, is that you can create a branch only one level, right? So you create one level. Sometimes here, like I have a branch data frame here. Hey, you know what? I want to create a branch from here, right? And that's somehow like you can't do it now. But other than that, for example, in this case, this one is when you see it, this branch data frame, somehow branch root is after the 7th step in the main data frame or parent data frame. And then, you know what, like I want to go back, and then because I'm actually adding some new step, or I removed some steps. So like I want to change this branch instead of starting from here. I want to start from the step 4, or maybe like I ended up like adding another 3 steps, and I want to move it or something like that. And you can actually drag and drop. So hey, you know what? Like I want to have this branch to start from step 6, and you can do that as well. So for that matter, there's no limitation. And then you can copy and paste any steps into from the parent, not from parent, but as a branch to this branch data frame. You can do that as well. I think maybe like worth mentioning is only one thing is there is something called a circular dependency. So let's say you use this data frame to kind of join, and then but somehow like in the parent data frame, and you let's say, oh yeah, so this is like a child data frame, right? Or a branch data frame. You did something here, and then the result of that, like you want to go back to the branch data, parent data frame. And then you want to actually join back together or something like that, right? To join back the branch data frame to the step 3 in this case. Then the relationship is kind of going round, right? So like it's basically becomes the infinite way of the relationship. So that you will get the error. We do the invalidation check behind the scenes, so you get the error. So, but that's a limitation. But other than that, it's pretty flexible. Did that answer to your question?
Yeah, no, and I think that circular, looping that you're talking about, that's helpful to keep in mind. And did you and you said that you're planning on doing some new additions to the branching?
Yes, we are planning to do more multiple levels.
Okay.
Yes. So yeah, we have been moving a little slow these days because we want to make sure that quality side of things. And then, so we are releasing like next patch set tomorrow, like 6.9.5. Even that, like we had to make sure that behind the scene, those like a step relationship works, pretty okay. But next release after that is at 6.10. I'm not sure 6.10, which you're expecting to release around May or June timeframe, and then we can make that happen. Or if anything might slip to the 6.11, but we're trying to do it in a sooner rather than later timeframe.
That's awesome. That's awesome. Thank you.
Sure.
One last question.
Yes.
And this is not an issue for me, but one of the things that I'm noticing is the size of the application is getting big. Is there any? And I don't have a problem with that. I mean,
yes.
I just have the equipment for it, but I'm just wondering if that at some point becomes a problem for, when you're trying to democratize data and you're trying to bring this analytics to the to the front.
Yes.
And they may not have, the equipment to do it
right.
because, such a big space. But I don't know if that's just the nature of software development, and that's just the downside that you can't control. Just wondering about that.
Yes. Thank you for that question. That's a good point. I think two things. The number one is Exploratory use a lot of our packages, and then throughout the history, like we tend to add more packages than removing packages. So that's the kind of one tendency, especially like size becoming bigger and bigger. So that's one part that like we are reviewing all those underlying our packages, and because some of the packages we are no longer using them. Or we have better way to do things because we wrote by ourselves. So that part, I think you're going to see kind of reduced size of the number of the packages that will help Exploratory and size to be smaller. Another area is that this has nothing to do with the the size of the Exploratory itself when you download from our page, but when you upgrade, like especially Gustavo, like you've been using for like maybe 3, 4, if anything 5 years, that means Exploratory has gone through a lot of upgrade, especially the major upgrade. And with that, sometimes like we had to upgrade our version from like our 3.0, 4.0, 5.0, or something like that. Every upgrade of the R, that means we need to upgrade the R packages as well, because R packages are depending on the R itself. So those, let's say like older version of the R packages for the R version was still there under the repository, Exploratory repository. That's where we install R packages. And we haven't cleaned up yet, which means in your repository folder, like there are tons of like the R packages just sitting there, not even used, like older version of the R packages. So let's say like a dplyr, that's one R package. But there's one dplyr for the current version of the R, which is, I forgot what that version is, but let's say like 6.0 or something like that. There's another version for like 5.0, another one for the 4.0. So these types of kind of, in a way, it's not garbage, but it's kind of garbage things being accumulated under the repository. And that's something that we are working on to, when you upgrade, we're going to take a look at it. And then if we think we are no longer using it, and we're going to remove it or something like that. So that's something we are looking at in the near future as well. Oh, Gustavo, you're on mute.
Oh, sorry. No, yes, thank you. I appreciate it. That's all I have.
Okay. Okay.
Again, thank you. As always, we're very grateful for your work. Very exciting.
All right. Thank you so much for joining, Gustavo, and hope to see you next week.
I'll see you.
All right.
Take
Have a
care.
good rest of the week. Bye.
You too. Bye.